Can you see that on the screen? Hello,
Yes,
Fatima.
I'm seeing.
Okay. So our first topic is a binary system, as already mentioned, and this is one of the topics in which you can be assessed upon in your junior school certificate examination. Can you hear me?
Yes, I'm seeing.
Some of the things we'll be looking at the binary system generally. We'll be looking at how to express numbers in basis and other basis, and then we'll be looking at how to convert numbers from base 10 to another basis and vice versa. Then we'll be looking at some of the how we can convert numbers from base 10 to base 2 and vice versa, as I said. We'll be looking at addition, subtraction, and multiplication of binary numbers, and we'll be looking at the application of binary system. These are some of the things that we're looking at on binary system. I hope you
Yes,
can hear me very well.
yes, I understand.
Okay, very good. So now binary system. From what you can see on your screen, a binary number is made up of zeros and ones. So when we have binary number, its binary numbers must always consist zeros and ones. So example, we have 1 0 1 0 0. This number now is an example of a binary number because it has already followed the rules that binary numbers have. Remember, we said the binary number is made up of zeros and ones. Do you get that?
Yes, I'm there.
Very good. And if you look at that, we said there is no 2, 3, 4, 5, 6, 7, 8, or 9 in binary. So
Yes,
binary only composed of 1 and
I'm
0.
zero.
So when you have 1 and 0, that number is a binary number.
Yes,
Then we also have what we call a bit. Are you with your pen there? Can
yes,
you write?
I'm with me.
Okay, so if you need to jot something down. So we also have what we call a bit. A bit is
Okay.
a single binary digit. The number above has 6 bits. That is each of these numbers. Can you see this?
Yes,
1, 1, 0, 1, 0, 0. All these numbers here, they are bits. So, and if you count them, that is, this is 1 bit, another bit, another bit, another bit. So if you count all these bits, that will sum up to your 6 bits. That is, we have 1, 2, 3, 4, 5, 6. So the total number we have here is what 6 bits. Is that okay? So once again, a binary number is made up of zeros and ones. So then we also have what we call the bits. So each of these numbers that make up a binary number is what we call. Do you get that?
yes,
Is it clear?
yes, it's correct.
Very good. So let's move on. Now they say most people count in tens, and if we also look at it, look at this number you can see on your screen.
Mm.
Can you call out these figures?
4956.
No. If you want to call it, you
Four
know you are
four 4,956.
very good, very good. So now, if you look at
Mm.
this 4 year, when you pronounce it, you said 4,000. You get that? This
Yes,
now has 4,956,
and 6.
telling us that this 6 is the unit.
Yes,
That is the last number. So when we have two numbers, that is 5 and 6, starting after 9, the next number we are going to have is 10. So from 1 and 0 up to 99, any figures you are having that consists of two numbers be made up of 10 numbers. Do you get that? So this is what
yes,
5, This 6 is units, the 5 is tens, the 9 here, because if you have to pronounce 956, it's going to be 956. So the 9 will be under 100, and the
mm,
4 will be under 1000.
four,
Together. So
yes,
the place values are in power of 10. Therefore, it is a base 10 system. Because if you try to look at it again, if you look at these figures again, you can say this is 4,000, this is
900,
900, and 1,000 has how many zeros? 30,
four,
100. Do you get
yes,
that?
yes,
100 has how many zeros?
two zeros,
20, 100. Then 10 has 20. Do you get it?
yes,
And this is just a single number, which we are going to talk about later on. So that's what they
mm,
mean here, that the place values are in power of 10. And if you look at it, we can uh, we can make all these thousands, all the thousands, hundred, we can leave
mm,
them in power of 10. So that's
yes,
why we call them as a base 10. So we are going to look at this. For example, the number again, we have 4,956. Do you get that? So this
yes,
simply means 4 times 1,000. Can you see that?
yes,
Because this 4, remember I said earlier, is under 1,000. That's why
yes,
it is 4 times
times
1,000.
100,
4 times 1,000. Do you get it? And the
yes,
9 we have here is under what? The
100,
value of 9 we have here is 100. That's why we have plus
9 times,
9 times
9 times
100.
100,
Then the 5 we have here is under 10. That's why we have 5 times
5 times 10,
and remember, I said earlier, one,
this
this
is
figure is
a
just
single,
because it's a unit. Whenever you hear the word unit, simply means one. You get it?
yes,
So
yes,
that's why we have 6 times one. Is it clear now? So
yes,
this numbers now has been expressed in power of 10. You get it? So
yes,
now to continue, this 1,000, I said we can just break it down in power of 10. And if you look at this, it will be 4 times 10 raised to power 3. I hope you understand how we get this 10 raised to power 3. By the time we multiply 10 in 3 places, if we multiply 10 by itself in 3 places, that's going to give us what? 1,000. And the fastest way you can just get that is you just count the number of zero we have. If you look at this 1,000,
yes,
you see that the number of zero we have is what? Hello?
yes,
The number of zero we have under 1,000 here is what?
it's 3,
Is 3. That's why we just have 10 raised to power 3.
3,
Do you get
yes,
that now? So
yes,
4 times 10 raised to power 3 plus, we are expressing these, all these expressions, we are expressing them in power of 10. Do you
yes,
get it? So this
yes,
102 is just going to be 9 times 10 raised to power 2. And if you count the number of zero we have under 100, it's going to be what? It's going to be 2. That's why we have 10 raised to power 2 for 100. Then if you move on, we have 5. I will say 5 times 10 because 5 under here is 10. So now, how many zeros do we have here?
1,
1. And that's why we have 10 raised to power 1. Hope you are getting it.
yes, I'm good,
Very good. Now, this one now that we have 6 times 10, 1. You can't leave this one like this because they've already instructed us that everything has to be in power of what? In power of 10. So this means that 1 that we are having here has to be converted to 10, has to be in 10 as well. Now, it's going to be 6 times 10 raised to power 0. This simply means anytime you are any number that is raised to power 0 is going to give you 1. It's not only 10. If you have
yes,
2 raised to power 0, you are going to have what? 1. If you have 3 raised
mm,
to power 0, you are going to have 1. If you have 20 raised to power 0, you are going to have 1. So any figure that is raised to power 0 is going to give you 1. So this simply means, and because we have been using 10, 10, 10, that's why we use 10. Yeah. Do you
okay,
get that? So we
yes,
just raise it as what? Power of 0. So that's why
yes,
we have 10 to the power 0. So let's move on. Now let's look at other examples. Now, I hope you can see that.
Yes,
The
I'm
question
seeing.
goes expand. The first question we have 320745. Now, to call this, you look at it, we call this base 8.
Yes,
320745 base 8. So if you want to pronounce it, just say 320745 base 8. So they said we should expand 320745 base 8 and power of their basis. So we are going to consider the first question. Later on, we are going to look at the second question. So the first one we have here is base. So they said we should what expand these numbers and power of their basis. And the base this number is having is what base 8. So they
yes,
are asking us to expand it to base 8. Do you get that? So let's
no,
look. You didn't get it?
yes. How did we get to say
Oh, it's a
that? Is,
question. You remember it's a question. They said
yes,
expand 32. This is question one.
yes,
Do you get that? This is question
yes.
one, this is question two. So we have two questions under this example. Do you get
Okay,
that? So
yes,
the first question is this one I'm showing here. So they said we should expand 320745 base 8 and power of its base. So whatever the base that we have here, I'm going to explain further by the time we start solving it. So the base we have here is what we are going to use to expand this number. So if you look at the second one, we have 1101 base 2. Do you get that?
oh, yes,
1101 base 2. This means this 2 is the base of this 1101. So we have to use this base 2 to expand this number. Do you get it? So
yes.
now let's look at the solution now. Now look at the solution to the first question. We have 320745 base 8.
Mm.
Base 8. Now I said something earlier. If you look at this, if you want to pronounce this number, we are going to have what? If you want to call these figures out, I mean neglecting this 8, if you want to call this figure out, it's going to be what?
Three,
I'm listening.
uh, three, 300. I'm not understanding.
No, I just want you to call out the figure. We have 320745. If you have 100, that is 100. If you have 111, that is 101. This one now, I want you to just tell me.
Three, 300 and 320,745.
Right. Okay. Do you get that now? Now,
Yes,
if you look at it, that means the number of zero you are going to have. Let's say this is zero, 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 zero. Hmm? Hello, hello. Can you hear me? Hello.
yes, I'm listening.
Okay, very good. Now that we are having base 8 here, this simply means we are to express this number, we are to expand it and what and power of its base. So now, for the easiest way and the fastest way to just get this is that this is 5, right? This is
Yes,
4, this is
yes,
7, this is 0,
yes,
this is 2, and this is 3. Now,
yes,
you can start from this 5. You can just take your pencil, something like this.
yes.
Let me,
Hello?
hello, I'm with you, I'm coming. I want to show you something.
Yes,
Now, if you go up, okay, you can just say 0. Are you getting that?
yes.
1. You can just use pencil.
Okay,
2. this one will be 2. I'm sorry, this I'm trying to use something that can be easy to draw this. So you can just continue that way. Do you get what I'm saying?
Yes.
So you can just take this is 0, is 0, 1, 2,
Two,
3,
three,
4.
4, 5.
So this here will be what? 5 on top. Now,
Yes.
do you get that? Do you get the
Yes.
logic now? Now,
Yes.
what you now need to do is you just take the first one, 3.
Mm.
Don't forget 3 times 8. The reason why we have 8 here is the base. You've already
Oh,
been instructed to expand the number and power of the basis, which is what? Which is 8. So the
yes.
base you are having is what you'll be using. If you remember the previous one we have, that one doesn't have any base. But they asked us to what? Convert it to expand it and what power of base 10. But this one has been given base 8. So we now be expanding it with 8. Now
Yes.
you pick the first number here. Don't forget you've already highlighted it 0, 1, 2, 3.
Two,
You always
three,
start from
four.
0. And when you are starting your 0, you start from the right hand side, which is from here.
Yes.
0, 1, 2.
2, 3, 4,
So
5.
now it's going to be 3 times
Yes.
8 because we are having base 8. 8 raised to power 5. Because these 3 now, what the number you are having on top is what? Is 5.
Yes.
Do you remember? It's
Yes.
5. So now, huh?
Yes, I'm listening.
Okay, okay. Now you are not going to have 3 times 8 raised to power 5 because if you remember it's 0, 1, 2, 3, 4, 5. This one take 5. Now you go to the next one
Yes.
plus. Don't forget your plus. Plus the next number is what? The next figure we have here is what?
2,
2.
2,
2 times we are still dealing with base 8. 8 raised to power. If you look at it, what you have under 2 is what?
4.
4. That's why we have 8
Yes.
raised to power 4. Do you get that? Now, 0, you
Yes.
pick 0 plus 0 times 8 raised to power
8.
3. Because under here we are having what? 3. Then
Yes.
plus the next figure,
7.
7.
7.
7 times 8 raised to power 2.
2.
You get that? Then
Yes.
plus the next the figure is what?
4. 1.
4 times 8 raised to power 1.
1.
And the next one is what? 5
5
times
times
8
8.
raised to power 0.
0.
So that is just the answer they asked from us. That's just what
Yes.
is asked from us. When they
Yes.
say expand the figure like this, and you are giving the base and power of the figure. Is it clear? Hello?
Yes.
Do you understand?
Yes, I understand.